Now, we're going to continue on in our notes, and we're going to learn polyatomic ionic compounds. I told you the ones you need to memorize are in the study stack. Now remember that anions are negative ions, and negative ions that contain oxygen are called oxy for oxygen, oxyanions, negative ions with oxygen. The form with the fewer oxygen atoms when you have an oxyanion ends in "ite," and the form with more ends in "ate." And there's a list of the ones I want you to memorize, and we're going to remember a couple of different things. I have 8, bigger, eat, smaller. So 8 and ite. The 8, ite. The bigger one eats the smaller one. The more oxygens you have, the bigger it technically is. Now I'm going to look for a moment at the polyatomic ion chart. Here they are. So let's look at, there's carbonate, chlorate, chlorite. So chlorate is ClO3. It has 3 oxygens. Chlorite is ClO2. It has 2 oxygens. So let's look at these for a minute. There's also things like hypochlorite and perchlorate. So chlorate is ClO3. That's the thing I need to look at the most. So I'm going to write it off to the side for a minute here. ClO3, and was that a -1? Double check it. ClO3 -1. Okay. -1. This is called chlorate. 8. And so if it has less, it has ite, because 8, ite, bigger eats the smaller one. There's a mnemonic device, a way of writing that. I can't remember at the moment. But so ClO2, that's smaller, is chlorite. Okay, now we're going to have hypo and per. And so we have to figure out which one goes on the top and which one goes on the bottom. And I'm going to see if I have them on here to find any examples. There we go. Perchlorate is ClO4. And then hypochlorite is ClO. Now, you notice they're just in alphabetical order over here. It's kind of better to look at them over here. Chlorite, hypochlorite, chlorite, chlorate, perchlorate. That's kind of the opposite way I write them. But the per is bigger and the hypo is smaller. Okay? Per is bigger and hypo is smaller. So it's going to go per, 8, ite, hypoite. That's how the names end. Per 8, ite, hypoite. Per 8, ite, hypoite. Per 8, ite, hypoite. This one has the most down to the, and then the smallest amount of oxygens. The top one is the most. Okay, so perate, perchlorate would be ClO2 minus. And hypochlorite would be ClO minus. So it's perate, ite, hypoite. Perate, ite, hypoite. So there's one called bromate that you have to know. And I'm going to, this one comes from bromate. And we're going to get to that one in just a minute. This is sulfate. And you have to know sulfate and sulfite. Sulfate is SO4 and sulfite is SO3. It's C8 and ite. If there's only 2 of them, the larger one, the one with the more oxygens, is 8, and the smaller one is ite. Per 8, ite, hyporite. Write that on your notes. Per 8, ite, and then hypoite. That's the order. Larger oxygens to smaller number. Larger number of oxygens to small number of oxygens. Okay? Now, what about sulfate? Sulfate has SO4. So sulfite would be SO3, and hyposulfite would be SO2. And persulfate would be SO5 if there was such a thing. Okay? So you just go up and down depending on where you start. Perate, ite, hypoite. So how do we name these things? This is sodium. And just like before, we just write the name. And SO4, you have to recognize, see it has sulfur in it? Sulfate. All right, sodium sulfate. Sulfate has a -2 charge, and so sodium has a +1 charge. And I know that because put the charges on the top, swap and drop, or pick the charge back up and undo the swap. So the 2 goes over there, and there's 1 sulfate ion, and it goes over here. So this is sodium sulfate. Now these are kind of difficult, so we'll keep trying. Look, this is magnesium. Magnesium. And then we have NO2. NO2 is one of the ones you have to memorize. And let's also look at the chart. Here it is. For NO2, notice that this side is alphabetical by the formula. So NO2 is nitrite. NO3 has more nitrogens, it's nitrate. Okay? So nitrite is NO2, nitrate is NO3. So it's whichever one has the most. So this is nitrite. And you'll get to use the polyatomic ion chart on the test, but you do have to memorize many of them, and I give you a quiz on that, a matching quiz, just to get them in your brain. So this is nitrite. So let's just look at this for a minute. If NO2 is nitrite, then what is nitrate? NO3 is nitrate. What would be hyponitrite? That would be NO, NO1. And then pernitrate would be NO4, because it's perate, 8-ite, hypoite. Perate, 8-ite, hypoite. Okay, now let's go to the next one. This is got 2 polyatomic ions. You have to memorize both of them. There's the first one you have to know, and then there's the second one you have to know. And you have to memorize them. Go to the study stack. This first one is ammonium, and you should be able to see it on the polyatomic chart. NH4, ammonium, it has a +1 charge. So ammonium. And this one is bromate. Let's go look. oh for goodness, I've got BRO3. So let's look over here, find BRO3. There it is, bromate. BRO3, bromate. Now I actually am having you memorize more than bromate. So this is bromate. But let's look at that one, okay? I'm going to write them off to the side and add this to your notes. Bromate is BRO3, and it's a -1. So if it's perate, this would be, it's per bromate, perate. So per bromate, that would be BRO4. And then bromite would be BRO2, and hypobromite would be BRO. So it again is perate, 8-ite, hypoite. Perate, 8-ite, hypoite. 4, 3, 2, 1. Most oxygens, least oxygens. Perate, 8-ite, hypoite. And if you don't see a perate or a hypoite, then you do just these two, bromate, bromite. Okay, perate, 8-ite, hypoite. Now let's look at this one. What is the formula for potassium dichromate? This one is tricky. Potassium is K, has a +1 charge. I can look at the oxidation chart and see that. Dichromate, that almost sounds like there's 2 chromates, and that's why this one's tricky. I don't know if dichromate's on here. Do they have even chromate on this one? There's chromate, CrO4. This one does not have dichromate on it. Okay? I'm going to have to pull up a different resource real quick to show it to you. But it is not 2 chromates. So just give me 1 second. Okay, I was trying to find just the dichromate ion, but here, this is potassium dichromate. Potassium is here, and the dichromate ion is CR2O7. Cr2O7. And so it's this yellowish compound, the potassium dichromate. And you can see up here, like there it is, Cr2O7. It has a -2 charge. Cr2O7, it has a -2 charge. So I'm going to write that over here. Cr2O7, that is dichromate, and it has a -2 charge. So the di here comes from the fact we have 2 chromiums stuck in this polyatomic ion. It is a weird one. It is a weird one you have to know. The chromate ion is in your polyatomic ion chart, is listed there. Chromate, CrO4. Dichromate is Cr2O7. Oh, there it is, right there. I didn't, it's because it's in alphabetical order, so I should look over here. CrO4 is chromate, and there's dichromate, Cr2O7, -2 charge. All right, all that fussing for nothing. All right, so now charges on the top, swap and drop. So it's K2 and Cr2O7, because the 1 would come over there. This is the polyatomic ion. You only have to put it in parentheses if there's more than 1, but there's only 1, so you just write K2 Cr2O7. Dichromate. Okay. All right, that brings us to ionic compounds and multiple oxidation states. And so we need to cover this in order to be able to finish up your worksheet. Ionic compounds and multiple oxidation states. So we've done ionic, metal on metal ionic, and we've told you that they don't use Greek prefixes. They can use Roman numbers though. And I like to write ionic with a big I, ionic, because that I looks like the Roman number 1. Okay? So you need to check, does the cation have more than 1 possible charge? So the question is always going to be, does the positive ion have more than 1 possible charge? More than 1 charge. So we look on the oxidation chart to figure that out, and then we use the Roman numbers. So I look, this is Hg, which is mercury. Okay? So I just write the word mercury, just like I've been doing before. I didn't write that too neatly, but it's mercury. All right, now let's go to our oxidation chart. Find mercury. And mercury is one of those that can be a liquid and at room temperature, and it's a metal. And I always struggle with finding mercury. So where is it? You probably have seen it. Hg, that's what I'm looking for. Mercury, mercury, mercury. All right, I'm going to have to go carefully through this now. There's silver. There it is, Hg, way down there, number 80. It has a +2 or a +1. So yes, the first atom that's positive has more than 1 charge possibility. It's ionic because it's a metal. So it could be a +2 or a +1. This is bromate. And I looked up here. We used bromate a few minutes ago. Right there. Bromate has a -1 charge. Okay, so what charge of mercury am I using? If bromate has a -1 charge and there are 2 bromate ions, then a -1 times 2 is a -2 charge. The negative charge is a -2. There's only 1 mercury, so in order for it to balance out and equal 0, I have to use the +2 charge. Because a +2 and -2 equals 0. I have to use the +2 charge. It had 2 options. I have to use the +2 charge. Mercury is a metal, non-metal, ionic. I have ionic compounds. So what the only difference now is I have to tell myself in the name which charge to use. I'm using the +2 charge, so I put the Roman number 2 in the parentheses. That means mercury uses the +2 charge and bromate is the second ion, the anion. They put the parentheses, the charge of the first atom, only if it has more than 1 choice. So the question always is, does it have more than 1 choice? If it does, use Roman numbers. Okay, so let's look at this one. This is lead, which is Pb. There's the parentheses, which means I'm going to use the +2 charge for lead, because lead which is also in your oxidation chart, Pb, has a +2 or a +4 charge. I'm going to use the +2 this time. And then sulfate is SO4 minus 1. And I'm gonna make check. Maybe that's wrong. Maybe it isn't a -1. Look at the polyatomic ion chart. Find sulfate. Oh, it's a -2. Okay, so go back up there and change it. It's a -2 charge. So +2 and a -2 already equals 0. So the formula is just PbSO4. All right. What about this one? This is lead and an SO4 with a 2. Well, lead, I don't know because, see, the lead has the option. This one told me to do lead 2, and sulfate is a -2. Well, sulfate's a -2, and I have 2 of them. I know that lead can be a +2 or a +4 because I can see that on the oxidation chart. Lead +2 or a +4. Sulfate is a -2 though, and I have 2 of them. So a -2 times 2 is a -4 charge. So the total negative charge is -4. Notice that this molecule has no charge, so that we're going to use the zero sum rule. It equals 0. I only have one lead ion or atom, so there we go, lead. So lead -4 equals 0. So lead has to equal a +4 this time. That's it. I'm using the +4 charge. So how do I name this guy? Well, it's still lead, but it's a metal with more than one choice in the first atom. So I have to tell you the name of which charge to use. I'm using a 4. I need the Roman number 4. And then sulfate. So this does not tell me that I have 4 lead atoms. I only have 1. This tells me the charge, the oxidation number of the first atom. I only use Roman numbers for the first atom, not the second atom or second ion. And that's how you knew those. So let's try another one. What's the formula for lead 2 phosphate? Lead is Pb. But lead can be a +2 or a +4. We just saw that on the oxidation chart. What is phosphate? I go to your polyatomic ion chart and I find phosphate is PO4 3 minus. PO4 3 minus. So I write PO4 minus 3 and I say, okay, lead 2 phosphate tells me to use the +2 charge. So I don't even have to use the 4. So now I have my charges. This parentheses tells me the charge. It tells me to use the +2. It does not tell me that I have 2 leads. It tells me to use the +2. Put the charges on the top, swap and drop. Different charges on the top, swap and drop, swap and drop. So that this is PB3, and then put the animal in the cage, put the monster in the cage, the polyatomic ion in the cage, and I have to have 2 of them. So this means 2 polyatomic ions. So this molecule is actually 3 lead ions, 3 lead ions, and 2 PO4s bonded together. Each PO4 has a -3 charge. Each lead has a +2 charge. Add all those +2s together, I get a +6. Add those 2 -3s together, I get a -6. And it adds up to 0. It adds up to 0. All right, that's going to bring us to hydrates, and we're going to stop here on this video. Oh, actually, no. We're going to go look at your worksheet again. So let me pull up the worksheet. Okay, I pulled up naming binary ionic compounds, which you should have already started. So if you don't have it, stop the video real quick and pull it up. We already have done some of these. So now what we're going to do is the ones that have some of the harder ones. Okay, we're going to go ahead and do number 3 together. Number 4 and number 5, and then I'm going to have you do some of the rest. So Ag is silver, okay, and O is oxygen or oxide, and I'm leaving a blank in case I have to write a Roman number. And then I go and look, okay, because Ag is silver is a metal, non-metal ionic. I go and look at silver on my chart. Silver is Ag. And I lose it as well. Oh, it only has a +1 charge. So that doesn't have more than one option. Silver only has a +1 charge, so it's just silver oxide, and that's all I needed to do. Okay? So I didn't have, this is just a +1, and that's a -2. I didn't have to do anything weird with that one. All right, about Cu. Cu is copper, and Br is bromine, becomes bromide. And I'm putting a space in case I need a polyatomic ion. I'm sorry, in case I need a Roman number. So let's go find copper now. Cu. Copper, there it is. It has a +2 or a +1. This one is a common one that has more than one charge. All right, so copper is either a +2 or a +1. I got to know which one to use. Well, bromine is a -1 because it's one of the fluorine, chlorine, bromine, iodine. So if this is a -1 charge total, I have to use the +1 charge to make this equal 0. So it has more than one option. So I have to put it in parentheses and put the Roman number 1. Now, when you're writing these names, you don't need all this space. It should just be silver oxide. Copper 1, that's how you say it. Copper 1 bromide. All right, we just saw copper needed a +2 or a +1. Bromine is a -1. So again, this is copper. And I know I'm going to have to use parentheses because it has more than one option for the first atom. Bromine is a -1. So what about now? Well, there's -1 times 2. That's a -2 charge. So it has to end in a -2 charge. Copper, there's only one of them. Copper -2 equals 0. So copper has to be the +2 charge because I add 2 to both sides. So copper is a +2. I'm using the +2, not the +1. So this is copper 2 bromide. Copper 2 bromide. Okay, so I've done those. I want you to try number 6 and number 7. Pause the video, work those out, and then once you've written them down and entered your answer, I will write it for you. Okay, I'm going to assume that you've done it. So this is iron and oxide. And iron is notorious for having more than one oxidation state. Iron is a +3 or a +2. So it's a +3 or a +2. Oxygen's a -2. So this iron has to be a +2. And since it has more than one option, I've got to put it in parentheses, use the +2. Iron, use the +2, oxide. This is iron again. Oxide again. Iron is a +3 or a +2. Oxygen is a -2. 3 times a -2 is a -6. I'm going to add it and it's got to equal 0. There are 2 irons, so 2 Fe's minus 6 equals 0. So 2 Fe's equals 6. So Fe equals a +3. So that's how I determined to use the +3 charge, not the +2. So this has to be iron 3 oxide. And the other thing is, we look at this, and we said, put the charges on top, swap and drop. And the other thing is, pick the charges back up and undo the swap. And I would be able to see that that's a -3, and that's a, that's a +3, and that's a -2. By just undoing the swap. Same thing over here, except this one doesn't really work because when you see FeO, oxygen's a -2, so this has to be a +2. But the thing is, what makes this different is you have to realize there's more than one option for these transition metals, okay? So you have to take the time to double check the oxidation chart. All right, finish any that you have not done. Oh, I guess I should do some down here. Let's go ahead and do number 9 and 10, okay? Manganese is Mn. This is easy now. This tells me use the +2 charge. Oxide is oxygen. It's a -2. It already equals 0. That's the formula. Manganese is Mn. This tells me use a +3 charge. For the first atom, oxygen is a -2. Charge is on the top. Swap and drop. So we get Mn2O3. Mn2O3. All right, that's where I'm going to stop on this. I will see you soon, if I can get it to stop.